Hey! Today, we will be doing some sequences and series, some SNS. It's embedded in our hearts.
It is, very much.
The first little piece of math or equation we're going to show you is something called...
This is the nth term of an arithmetic series. And what I meant was a sequence.
No problem, continue.
So essentially what a sequence is a bunch of items in a list, and each successive item you're adding a common difference D. So we can have a sequence 2, 4, 6, 8, and so on. And you can see that every term after the previous term is increased by 2.
We could also have a Z, ZZ, ZZZ, ZZZZ.
So many ZZs, increasing the Zs.
Like a grandpa sleeping. Here, A1 is the first term. We usually have these Zs and 2s as our first term. Not exclusively, but in our case here. N is the total number. It could be finite. It has to be infinite. And then D is like the common difference, you know. The difference between each term to the next will be a constant amount. So we denote that as D.
D. So if we want to find the third term, we know that it's 6. So let's plug what we know into this formula. So we know that the first term is 2. And that the term we're trying to find is the third one. And that the common difference is also 2. And that becomes 6. If you don't know this, review some pre-algebra.
Yeah, you should be able to do this. No problem.
No problem.
6 is in our hearts. Anyways, this is all good, but we have more
It's
challenging.
not that beautiful, so we're gonna wipe this window.
We have more
clean.
handsome, more alluring, you know, something that has more vitality and vigor for us.
Yup. And we're gonna show you what a series is. So
Yeah.
we denote a series.
Series.
S letter. So the formula for a series is this really wacky thing that looks like it came from Mars or someplace. So it's this orange formula
orange.
that I can hope you can see.
Yeah, looks pretty good. That's a 2, not a Z. That's a 2, not a Z.
Yup.
Yup. And we're gonna actually show this one in greater detail for you guys, in case, because this one we know you can understand. This one's
It's a bit sussy, you know?
yeah, it's a little.
So first we're gonna give you an example of when to use this. So let's say you have a sequence that's like 3, 6, 9, 12, 15. Nobody wants to add all of these terms up in there.
Yeah, like in our day and age, just
come on. In our days,
we
just,
refuse.
we use calculators, but at present we have none.
Yeah.
So we just plug
This
it
is
into
our
this
calculator.
formula. It's like a machine. We put the Pascal
We love
in,
machines.
and it rolls it out.
Yeah.
Yup.
The orange ones.
So we know the common difference is
What is it again?
3.
It's 3. It's 3.
Wow. We know that the first term is also 3.
That's such a coincidence.
So let's plug these numbers in.
Yeah, let's do it.
So we want to find the sum up to the 5th term.
Yeah.
So first term, second
Second
term,
term.
third term,
Yeah.
4th term, 5th term.
There are 5 terms. Oh, by the way, guys, if you have a little trouble with this and we're going too fast, you know, don't stop the video, but take some free time somewhere else to do this.
Yeah. So we know that the first term is 3. Term we're trying to go up to is 5. The common difference, as explained before, is 3. So when we do this, oh, nobody likes doing this yet. However, but at least it's still better
It's
than
better than
adding.
that.
Yeah, it's better than adding everything up.
Do you want me to help you?
Yeah, help me. Dang,
Okay.
I'm not good at
So,
arithmetic.
this one looks kind of funky. We're going to leave it as is. We're not going to delve into those dirty little decimal beasts, you know.
Nobody likes
But
decimals.
we're going to do this. We're going to change this to 6. because 2 times 3, as any 4th grader would know, is 6, right? And 5 minus 1, that's 4. And we're going to move the 3 down like quotient. Long division. And this will be simplified further into 12.
Wow.
See? We're going to rewrite this, alright? Actually, no. That's 2 cringe.
Cringe. And we add these two together.
Yeah, we're going to go
Which
to
makes it
5, 2.
18.
Oh, Shiba! Now, how are we going to do this? This looks too complicated. We want to get rid of this 2, right? So,
Yeah.
this thing, we're going to turn it into 2 times 9. And we're going to move the 2 over here.
This
and it's going to be 5
doesn't look like a 9,
times
but it is a 9.
which is equal to 50, no, 45! Yay!
Yeah. Easy class.
Alright. Now, okay, so
Now
this is our
let's erase
example.
this, 'cause
Now
it's
it's
so
time
much.
to actually prove it. While Mr. Unpaid Gender does the job here. Oh,
We're gonna
actually,
erase this because this looks like a Skittles commercial with the colors of the rainbow.
Yeah, not very
Yeah.
tasteful. You know, blue Skittle. Actually, they're pretty good.
I don't know. I've never tried a blue Skittles.
Really?
If there is one. Now we're gonna prove this baby.
Yeah.
So we prove this formula by looking at. Damn.
What?
We don't get paid enough to get good markers. Oh my.
SN.
Yup. So the first term. So the sum of all of the terms is essentially the first term plus the second term, which is the first term plus that common difference. Yup, exactly. And then we add it all the way to the nth term.
Yeah. This should be pretty simple to understand. We'll separate these for you right now.
In case you have some eye trouble, you know.
Yeah.
We're just helping.
Or if the slant is kind of hard on your eyes.
So the sum is also this, but
Mhm.
reversed. So we can rearrange it. So we can start all the way at the end, then add the second last term, which is that last term subtracted a common difference,
Subtracted.
and all the way back to the first term. So notice how
Yeah.
we're going in reverse this time.
Forgive our equal signs not lining up. I know that your 7th grade teacher might have taken marks off for not lining up your equal signs, but here,
Yeah, I hated that.
here we're not into that, you know? We just want to add, we don't want to worry about equality. Actually, we love equality, but we don't want to worry about mathematical inequality.
So we add these two sums up, and now we get 2 of the sums.
Yeah, so we're going to have a big fat O2 here. Would you like to
Yup.
do? Shit.
Oh my Shiba.
Dude, can you, like... We actually don't get paid enough, okay? Does this one work right?
Yeah, we're switching markers, maintenance. moment.
Maintenance, sorry.
Maintenance.
You can pause now if you want.
Yeah. This is when you
Yeah, this is your
delve
break.
into your thoughts. So when we add these up, we get 2 of the first term plus n minus 1d, and we get 2 of the first term again plus n minus 1d. And I'll show you why this works. So you can see how there's 2 A's,
Yeah.
2 A's,
Mhm.
and the n minus 1d.
The extra. The loose flab that needs to be ejected.
Yup. And now here, d plus n minus 2d is basically n minus 1d.
Yeah, it's transferred.
Because you're adding a d to the subtracted.
Yeah, you're
d.
adding a D to get n minus 1.
Like Ivan D.
Ivan D.
Ivan D.
Yeah.
Yeah. And this goes on n times.
Yeah.
So when we do the formula, we get Sn equals n times of this divided by 2. We get the beauty.
And looky here.